Okay, this is a video on the atmosphere and environment Mindmap. Now, this chapter centers around air. Now, air is a mixture of many different gases, and the composition by percentage volume of the different gases would be 78% for nitrogen, 21% for oxygen, 0.03% for carbon dioxide, and the rest, which is around 0.97%, would consist of noble gases, which is mainly argon, as well as water vapor. And out of this 0.97%, bulk of it actually consists of noble gases and argon. Water vapor is very little. And of course, the percentage compositions of water vapor would depend on the humidity of the air. Okay, so you have to memorize this percentage composition by volume. Now, the different components in the air can be separated by fractional distillation. Okay, because the different gases in the air would have different boiling point. So the first thing that needs to be done is to cool, as well as to compress the air into liquid air. Okay, and then once it turns into liquid air, then it will be heated. So this entire process is the fractional distillation. So it needs to cool, to be cooled, to be compressed, and then after that to be heated. Okay, whereby it was subject to fractional distillation in the fractionating column. And you need to be aware that the component gas with the lowest boiling point will distill over first. So nitrogen would distill over, because nitrogen has the lowest boiling point. So if it has the lowest boiling point, it will, once it is heated, it will become gas, the first, and it would rise to the top of the fractionating column, whereby it will be distilled over. Okay, so the gas with the lowest boiling point will get distilled over first, and then of course the component of gas with the highest boiling point will get distilled over last. So if you go up the fractionating column, the boiling point of the gas component will decrease. Then the next part would be on the pollutants in the air. Now, air has many pollutants. The first one is ozone. Now, ozone is an allotrope of oxygen, very much like carbon. Okay, carbon has two allotropes, which is diamond as well as graphite. Okay, so ozone is an allotrope of oxygen, and you need to know what is the meaning of allotrope, different forms of the same element. So the properties of ozone is it is a pale blue gas, it is toxic at high concentration, and the function of ozone is to shield UV light at the upper atmosphere. And the cause of ozone can cause a respiratory problem. That means a breathing difficulty. It can irritate eyes and lungs. Now, at lower atmosphere, ozone is a pollutant, but at upper atmosphere, it is not. In fact, it is useful to us, whereby it shields the UV light. UV light or ultraviolet light can cause skin cancer. High exposure of our skin to UV light can cause skin cancer. Now, ozone at a lower atmosphere can form photochemical smoke. Okay, now what is photochemical smoke? Now, photochemical smoke, basically, it looks something like this. Okay, it makes the sky look very blurry. Now, what is it actually? It is actually a pollutant, whereby it is formed from the reaction between ozone. NOx stands for nitrogen oxides, whereby this X can be 1. If this X is 1, then NOx will become NO, which is nitrogen monoxide. If this X is 2, then NOx would become NO2, which is nitrogen dioxide. So NOx stands for nitrogen oxide, whereby it includes nitrogen monoxide and nitrogen dioxide. So this photochemical smoke is formed from the reaction between ozone, nitrogen oxides, unburned hydrocarbons. Now unburned hydrocarbons is from the exhaust of the vehicle, as well as sunlight. So when these four things react, it would form photochemical smoke, whereby it would make the city sky look blurry. Okay, now let's look at unburned hydrocarbons. So unburned hydrocarbon, so the second pollutant is unburned hydrocarbon. The main source of it is the decay of plants and animals, and of course the main source is the vehicle exhaust fumes, and it can cause cancer. It reacts with nitrogen oxides to form ozone, which in turn will form photochemical smoke. So that is unburned hydrocarbons. So these unburned hydrocarbons mainly is from the exhaust, whereby from the exhaust you can see the smoke. It's very blackish. So those are actually unburned hydrocarbons. Okay, pollutants. The third pollutants in the air is methane. Now methane is colorless and odorless, and the main source of it is decay of plants and animals, and the cause of it is global warming. So this methane is one of the greenhouse gases. Okay, I think in the next page of the mind map we'll talk more about greenhouse gases. The fourth pollutant is sulfur dioxide. Sulfur dioxide is colorless and pungent, and it is produced by volcano eruption as well as the combustion of fossil fuel. Now, what is the meaning of fossil? Fossil is the is the remains of living things. So, for example, petroleum is an example of fossil fuel, because petroleum is from the remains of living things thousands or millions of years ago. Okay, fossil fuel, sulfur dioxide. And then the next pollutant is oxides of nitrogen or nitrogen oxides, which include nitrogen monoxide. Nitrogen monoxide, also known as nitric oxide. These two, they are the same. So basically what they refer to is NO. Okay, and also it includes nitrogen dioxide. Now, these oxides of oxide of nitrogen is produced by lightning and the car engine. So basically it is produced by a situation whereby there is a very, very high temperature, thousands of degrees Celsius, as in the case of lightning or car engine. Now let's look at the car engine. What happened at the car engine? Now at very, very high temperature, as in the car engine, the nitrogen in the air as well as the oxygen will combine, will react to form nitrogen dioxide. And sometimes the nitrogen and the oxygen will combine to form nitrogen monoxide. So nitrogen monoxide and nitrogen dioxide are formed in this way from the reaction between nitrogen and oxygen. So they are produced at very high temperature. Now let's look at the car engine, what happened inside. Now, car engine, in order for the car engine to produce power, you need to mix the air and the petrol, and then after that burn it. Now there could be one of these two situations. Now in the instances of high air petrol mixture, which means that the percentage of air is very high, the percentage of petrol is very low. That means in the situation whereby there is a lot of air, very little petrol. So if you have a mixture of a lot of air, very little petrol, now what happens is there will be a lot of oxygen, because a lot of air means that there will be a lot of oxygen. So when there is a lot of oxygen in this reaction, there will be a lot of nitrogen dioxide produced, and also a lot of nitrogen monoxide. Okay, a lot of nitrogen dioxide produced. And at the same time, since there are a lot of oxygen, meaning that there will be complete combustion. Complete combustion means that where something is burned in excess of oxygen. So when there is complete combustion, very little carbon monoxide will be produced, because carbon monoxide is produced from incomplete combustion, whereby not enough oxygen. Okay, so in a high air petrol mixture, the result is a lot of nitrogen dioxide is produced, very little carbon monoxide is produced. And of course, for complete combustion, a lot of power will be generated. Okay, how about in the case of low air petrol mixture, whereby there is very little air but a lot of petrol? Okay, when there is very little air, it means that very little oxygen. Very little oxygen means that there is very little oxygen here. It means that very little nitrogen dioxide will be produced. Okay, so very little nitrogen dioxide. And very little oxygen also means that the combustion will be incomplete. When the combustion is incomplete, a lot of carbon monoxide is produced. Okay, so in the case of low air petrol mixture, a lot of nitrogen dioxide, a very little nitrogen dioxide is produced, a lot of carbon monoxide will be produced. So in either of this situation, high air petrol mixture or low air petrol mixture, there will be a lot of pollutants produced. These two are pollutants: nitrogen dioxide, carbon monoxide. So regardless of how you adjust the air petrol mixture, whether or not you use a lot of air, very little petrol, or very little air, a lot of petrol, there will be a lot of air pollutants produced. The difference would be which air pollutants will be produced more, which air pollutant will be produced less. Okay, so this is the trade-off between the oxides of nitrogen and carbon monoxide. Either way, air pollutant will be produced. Just a matter of whether there will be a lot of carbon monoxide or a lot of oxides of nitrogen. So this is a trade-off that the car engine, the manufacturers of the car engine will encounter in terms of making the car engine to be more environmental friendly. Okay, let's look at the next pollutant, which is carbon monoxide. Now these are the properties: colorless and odorless. Carbon monoxide, it is produced by incomplete combustion of fossil fuel. Incomplete combustion means not enough oxygen is available for the combustion. So when there is incomplete combustion, carbon monoxide will be produced. Now this carbon monoxide, as you have learned in the lower set, it will combine with the hemoglobin of the red blood cell. And the function of the hemoglobin in the red blood cell is basically to transport oxygen to the rest of the body cell. So if you breathe in carbon monoxide, this is what will happen. It will combine with the hemoglobin of the red blood cell. So the red blood cell, or so the hemoglobin, instead of transporting oxygen to the red blood cell, it will transport carbon monoxide. So you will have carbon monoxide poisoning, and all your other body cells would not get enough oxygen. So in short, your body cell will be deprived of oxygen, and then you will die. Okay, so this carbon monoxide poisoning causes fatigue, headache, breathing difficulty. So these are the pollutants of air. Now the next part of the mind map concerns the effect of the air pollutant, and the first effect. Okay, and the first effect is acid rain. Now, how is acid rain formed? Now, acid rain is formed mainly as a result of the air pollutants, of these two air pollutants, sulfur dioxide and nitrogen dioxide. So these two are acidic, and when they dissolve in the rainwater, it would produce acid rain. And the pH of acid rain is 4 or less. That means 1, 2, 3, 4. Cannot be 5, cannot be 6. Unpolluted rainwater has pH slightly less than 7. So unpolluted rainwater is actually acidic. Why? Because of the presence of carbon dioxide. There is already carbon dioxide in the air, and the carbon dioxide in the air, when it rains, the carbon dioxide in the air would dissolve in the rainwater to form carbonic acid, which basically makes the rainwater to be slightly acidic, because this is a weak acid. Now, how do sulfur dioxide and nitrogen dioxide form acid rain? So when sulfur dioxide dissolve in rainwater, it will form this thing called sulfurous acid. Okay, H2SO3, sulfurous acid. And this sulfuric acid will be oxidized by the oxygen in the air to form sulfuric acid. Now, how about for nitrogen dioxide? How does nitrogen dioxide contribute to acid rain? So when nitrogen dioxide dissolves in water, okay, and then it will be oxidized by the oxygen in the air to form nitric acid. So all these chemical equations you have to be aware of. You must be able to write them. And the effects of acid rain, it corrodes steel or limestone building. Because steel, what is inside? What are the things inside steel? There will be a carbon, iron, nickel, as well as chromium. So there are a lot of metals inside the steel, and as you know, acid reacts with a lot of metals. For example, acid and metal, acid and iron, there will be reaction. So it will corrode steel or limestone building. Limestone is basically calcium carbonate. So CaCO3 does react with acid to produce salt, water, and carbon dioxide. Another effect of acid rain is it leaches nutrients. So basically it removes the nutrients from the soil, and it would cause the plants to die. And acid rain also reacts with aluminum hydroxide in the soil. Okay, this compound is available in the soil, and when it reacts, it would form aluminum ion, which is toxic to the plant. So aluminum ion is toxic to the plant. So for example, this chemical reaction here, you have an acid, you have a base, okay, aluminum hydroxide, it is an amphoteric oxide, it is also a base. So you get salt as well as water. It reduces, acid rain also reduces the pH value for the pond or lake water, killing marine creatures. Now it doesn't react pH value of the sea water, because the volume of sea water is huge. So acid rain would have no effect on the pH value of the sea water. So when it comes to describing the effect of acid rain, make sure you are very careful. Don't say reduce the pH value of seawater. That is wrong. That is impossible. Now another effect of air, of the pollutants in the air is, the next part is, how do you minimize the effect of the air pollutant? Okay, in order to minimize the amount or the effect of air pollutant, we have to stop open fires. Okay, like what is happening in Indonesia. Also, we have to make a compulsory fitting of catalytic converters in all vehicles. So these catalytic converters, basically what it does is it turns pollutants into something not harmful. Okay, later in the next page of the Mindmap, we'll look at this catalytic converter. What is happening inside? It is fitted in the engine of the vehicles. Okay, liming of lakes and rivers polluted by acid rain. So what people do is to spray calcium carbonate, powdered calcium carbonate, to the lakes or the rivers to neutralize the the acid in the rain, in the lakes or the rivers. But the drawback of this liming of lakes and rivers, the drawback is it is expensive and the effect is temporarily. Why is it temporarily? Because if there is another occurrence of acid rain, it will turn the lake water to be acidic again. So the effect is not permanent, it is only temporarily. So you have to do it probably every few years or every few months. Depends on how often is the occurrence of acid rain. Okay, the effects of air pollutants, it would deplete the ozone layer. But first of all, you need to know what is ozone. Now the function of ozone is to absorb the harmful UV radiation from the sun. Okay, so the ozone layer actually provides protection to us against the UV radiation. And then what happened to this ozone is that if you use certain products such as aircon coolant or refrigerator coolant, as well as the aerosol, let's say your insect spray, your hairspray, they contain this, some of them contain CFC. So all these products, some of them they contain CFC, stands for chlorofluorocarbon. Now when this CFC reach the upper atmosphere of the earth, what happened is that the CFC will decompose to form a lot of chlorine atoms. Now, as you know, chlorine atoms are unstable because chlorine atom has 7 valence electron, so it is unstable. So these chlorine atoms would react with the ozone molecules in the upper atmosphere to form chlorine oxide and oxygen. So when this reaction occurs, the ozone will be destroyed. So the ozone, the O3, will be destroyed slowly by all these chlorine molecules, by all these chlorine atoms, and all these chlorine atoms come from CFC, chlorofluorocarbon. So this is what will happen. The ozone layer will be destroyed, will be depleted and then destroyed. So this is one of the effects of air pollutants. So the air pollutants in this case is chlorofluorocarbon, which comes from fridge coolant, aircon coolant, or the propellant for the aerosol, all those hairspray, insect spray, etc. Okay, another effect of air pollutant is the greenhouse effect. Now, greenhouse effect is the warming effect of the earth, and it is caused by greenhouse gases. And these are the 3 most common greenhouse gases: carbon dioxide, methane, and nitrous oxide. So too much of these greenhouse gases would cause global warming. And of course, we need to have greenhouse gases, otherwise Earth will become very, very cold, because the function of greenhouse gases is to trap the radiation, the infrared radiation from the Earth, or trapping the heat in the Earth. So without greenhouse gases, the Earth would be frozen, would be very, very cold. Now, if too much of it would cause the Earth temperature to rise. That means global warming. So the effects of global warming are unusual and unexpected weather conditions, such as all these droughts, hurricanes, floods, decrease in crop yields because more land would become deserts, and also rising sea level due to the melting of ice. So this is the effect of air pollutant, greenhouse effect. Okay, carbon cycle. What is carbon cycle? That is the mechanism or series of processes that maintains the level of carbon dioxide in the atmosphere. That is called carbon cycle. So, carbon dioxide is added to the atmosphere, carbon dioxide is also removed from the atmosphere. So carbon dioxide is added to the atmosphere mainly because of these three reactions here. Okay, combustion of fuel, respiration, decay or bacterial decomposition of living things. So all these three processes produce carbon dioxide. And these two processes remove carbon dioxide from the atmosphere. An example is ocean uptake. Seawater dissolves carbon dioxide, which is used by marine plants and organisms. So ocean basically serves as a giant carbon sink, whereby it dissolves a lot of carbon dioxide. And of course, carbon dioxide is also removed from the atmosphere through photosynthesis, which is actually the opposite of respiration. Okay, respiration, photosynthesis. Now, pollutants can be reduced by a catalytic converter or flue gas desulfurization. Now, let's look at catalytic converter. Now, what is this catalytic converter? Now, it is a requirement for this device to be fitted in the car engine. Okay, let me show you an image of this catalytic converter. Where is it in the car engine? It's not part of the car engine. It is fitted right after the car engine. This is car engine. This is catalytic converter. This is the exhaust pipe. So what happened is, car engine would produce a lot of air pollutants, and all these air pollutants would be converted to less harmful gases by or inside the catalytic converter, and then after that the less harmful gases would be removed through the exhaust pipe. So this is what happened. The input from the car engine, so the input gases into the catalytic converter would be from the car engine. So the hot exhaust gases contain carbon monoxide from the car engine, nitrogen oxides such as nitrogen monoxide and nitrogen dioxide, and unburned hydrocarbons. So those are part of fuel that is not burned completely. That is basically what this unburned hydrocarbon means. Okay, the components or the part of the fuel, of the car fuel, that is not burned completely. So when it goes into this catalytic converter, and this catalytic converter is coated with two catalysts, rhodium and platinum. And what happened is, the output of the catalytic converter, which form part of the exhaust gases from the vehicle, the output gases would be carbon dioxide, water, as well as nitrogen. So all these three are not air pollutants. They are not air pollutants. Now, so these are the reactions that happened that take place in the catalytic converter, and all of them are redox reaction, which means that oxidation and reduction take place in the same chemical reaction. So the first one is carbon dioxide. So this carbon dioxide here would be turned into carbon dioxide. Carbon monoxide would be turned into carbon dioxide. So the carbon monoxide would be oxidized to carbon dioxide, and the oxygen would be reduced to carbon dioxide. So there is oxidation, there is reduction. This to this is oxidation, this to this is reduction. You can look at the oxidation state to prove that. So this is a redox reaction. And of course, for nitrogen oxides, okay, nitrogen dioxide would be reduced to nitrogen, and carbon monoxide from here, also part of the hot exhaust gases from the car engine, it will be, so this to this is reduced, this to this is oxidized. So this is another redox reaction. And then let's look at the nitrogen dioxide. This to this is reduction, this to this is oxidation. Okay. Unburned hydrocarbons such as octane, so this is octane, so it would be oxidized to form carbon dioxide, and the oxygen would be reduced to form water. So these reactions, these chemical equations are very important, so you need to know how to write them. So all these are the redox reactions that take place in the catalytic converter that turns air pollutants from the car engine into less harmful gases, or into non-air pollutant such as carbon dioxide, water, as well as nitrogen. And the second way whereby the pollutants can be reduced is by this flue gas desulfurization. Now, what is flue gas desulfurization? Flue gas, the meaning of flue gas is waste gas from the combustion of fossil fuel. So in the factory whereby petroleum or the fossil fuel is combusted, is burned, sulfur dioxide will be produced. And sulfur dioxide, as you know, it is a contributor to acid rain. It is an air pollutant. So there are actually two ways to remove carbon dioxide. One way, of course, is to remove sulfur from the fossil fuel, but that is very costly. Another way is through this FGD, flue gas desulfurization, whereby the sulfur dioxide produced is removed from the waste gases. So that is basically what this FGD plant is for. So in this FGD plant, sulfur dioxide go into it, and then it will react with calcium carbonate. So these are the reactions in the FGD plant. Sulfur dioxide passes through either calcium carbonate, limestone, or calcium oxide. Okay, so this calcium carbonate or calcium oxide is mixed with the water, so they will become suspension. So sulfur dioxide react with calcium carbonate or calcium oxide to form calcium sulfide and carbon dioxide. And of course, in the case of calcium oxide, it will form calcium sulfide only. And this calcium sulfide will be further oxidized by oxygen in the air to form calcium sulfate, which is a solid. So the calcium sulfate would remain here, which can be removed later. So whatever gas that come out would be mainly carbon dioxide. So sulfur dioxide come in here, whatever that comes out from the chimney would be mainly carbon dioxide and air. Okay, so these are the reactions that take place in FGD plant or flue gas desulfurization plant. So as I mentioned, this